Hello, everybody. In this video, what we're going to go ahead and talk about is volume of pyramids, cones, and a few example problems here and there to go and work with. Okay. Now, when we think about the volume for a pyramid, we're thinking about the volume formula of base times height, but divided by 3. Now, for a cone, you just take the area of the circle times the height divided by 3. So just be aware of this. Now, the one thing about this that where you can see in real life, especially here in Houston, is that you can think about Moody Gardens. And when you think about Moody Gardens, you see the pyramids. And for those who have gone, these are always filled with people, they're filled with plants, they're filled with exhibits. And they're usually all inside here. So that's going to be considered the area of how much it can go and store of items and exhibits and people. Put them all together, right? Now, usually that's a pyramid. Now, when you think about a cone, a lot of people don't really think about the most. Well, actually, they probably do even think about this part when they think about the ice cream at the very bottom. Okay, that's the most delicious part of the drumstick. So you want to go ahead and consider that area that's within this, the volume that's within here is how much does it take, how much space does it occupy is initially what it is. So how much ice cream in total do you get out of this whole entire drumstick? Now, that being said, we're going to use these two figures to go ahead and figure out how to find the total space that occupies within it. Okay. Let's see. All right. Let's go over here then. Now, when you're looking at for pyramids, so you're going to find the volume of each pyramid and round to the nearest hundredth. As we go and solve this, you identify the base of each pyramid. So the base of this pyramid is a square. So that's going to be square. Here's another square to go and work with. Now, the further you go down, you might see maybe you see different ones. No, not for now. So for the pyramids, you probably see square majority of times. And so you just got to be able to go ahead and identify where it's starting. Now, in this one, for this green one, the pyramid happens to go ahead and be standing up, and it's not laying down, just like those Moody Garden ones. But we have to look for the base. So the height of this is what we're looking for too. Now, if we're looking for the base, that means I have to look for the area of this square. So that means it's going to be s squared, which will be 14 squared. And 14 squared is 196. 196 kilometers squared. Okay, so hopefully that was the easy part. Now, if we're trying to look for the height of this, which is the problem, we have to go ahead and look for this triangle right here. Now, when you look for this triangle, you have H, you have 25, and then this 14 happens to represent that whole entire line on the bottom. So we're going to go ahead and just cut it in half, and that's going to become 7. And then now we can go ahead and use Pythagorean theorem, a squared plus b squared equals c squared, to go ahead and solve what we need. So that'll be 25 squared, you have x squared plus 7 squared. And now when you solve this, I'm going to go ahead and square 25. Let's see. 25 times 25, which is 625, minus 49 on both sides. X squared is equal to 576. Square root it. So that means you'll get 24. So x equals to 24. So there you go. So your height here is 24. 24 kilometers. Now, as we go back to the volume, as we look at the volume, we have to go ahead and think of it as the 1/3 base times height. So we're going to have both of our parts that we need here to go and figure it out. So 1/3, my base is 196. and my height was 24. So you can multiply those out. And then you get 24 times 196 divided by 3. Let's see. 196 times 24 divided by 3. And you get 1568. So 1568 kilometers cubed. So that's how much area it occupies inside. Okay? Let's see. Yeah. Okay. So let's keep going. Now, as we're going with this, the cone is going to be one where you're going to have to go ahead and just break it apart for what we know. So the radius, like I said, when you have a circle, that's considered the diameter, and this is the radius. Half of this is going to be considered 8. Okay? So don't forget about it. Now the height of this is going to be 9. So that one's actually a little bit straightforward. So it'll be kilometers. And when we try and go and solve for this, it's going to be 1/3 pi r squared times height. So it's 1/3 pi. My r happens to be 8. And then my h happens to be 9. So that'll become 1/3 pi times 64 times 9. 64 times 9 divided by 3. So 192 pi. So when we go multiply that by pi, it should give you 602.88. Okay, and that's already rounded, okay? So 2.88. Let's go ahead and try and double check that. So 192 pi. Oh, never mind. Off by a little bit, guys. Let's go back to pi. So it should be 603.185. And when you round it, it should be 19 right there. So be careful what you're seeing. Okay. So it will come back when you need to go ahead and use the Pythagorean theorem to solve for the missing height of cones too. So you're going to use Pythagorean theorem during this section. So like down here, when we're looking for this height, it's not the actual, it's not 41. You just have a triangle that happens to be laying down. And this triangle is what you're going to try and look for. So this happens to be 41. We don't know this side. And then this happens to be 9 because it's right here. Okay? So just be aware. Plug it in with what you know. And then you can go ahead and solve it on your own, okay? Because everything out there is given for you already. So that's how do you find the volume of a cone and a pyramid along the way, guys, okay? All right, so tune into the next video. Go and check it out.